Hi, welcome. My name is Mahmoud, and this is Evan and Lakshan, and we're just part of a very big team of Unmanned Search and Rescue. And we're here to talk about this project and where it has taken us over the last 3 quarters. And so when we started, we had pretty much three specific goals. We had a mechanical goal, software goal, and a power generation goal. The mechanical goal was to build a plane that can take off and land vertically like a VTOL plane, and carbon fiber and all that. And we had the software goal, which was the search and rescue aspect of the plane. It was to input specific data about people and then output an area code and a search pattern for which the plane could go. And then the third one, to have a power generation goal, fully autonomous, and to have it all fully autonomous on the back. However, we obviously ran through problems as we went through the entire year, and I guess what we tried to do in the very beginning was to have a fully autonomous VTOL plane, and where we are today is a autonomous plane, I guess.
Alright, so project development. As of right now, we have done, we've used an RQ-11 to test our unmanned flight program so far. And as of right now, it has proven somewhat reliable, and it depends on how much of a range we get, and like the area that we are using to test it to be much bigger than Aldridge Park. And then manufacturing-wise, we have been working with carbon fiber. We were very excited to start working with it, but as we started working, like getting the hang of it, it just turned out to be a very difficult task because it's really hard. It doesn't like contour to what we want it to be. So all of a sudden, all of our designs had to be redesigned because of the fact that carbon fiber just does not like to stay on things. It's pretty strong, and it likes to like contour to its own method. And then for our VTOL aspect, we have pushed it to next year because we are planning to keep the project alive, and a new team will be taking over next year. And VTOL was one of the aspects that we got feedback from the industry, that they were quite excited about what we might be finding with VTOL, because it's something that the project has been opened up recently, and everyone's really excited about seeing how far anyone can get with VTOL.
So this quarter we've had a much larger team than we've had in the past. We started last summer with just about 10 or so of us. We moved on to about 20, 30 here in fall quarter, about the same during winter quarter, but during the spring quarter we opened it up to a lot more of underclassmen and whatnot, so we're working with a team of a lot closer to 50, which meant that our management structure has had to change significantly to be able to accommodate all the new members. So as you can see, we've broken it down into much smaller teams, a lot greater communication between the team leads, and weekly meetings of all sorts of open communication channels, and different teams working together for different goals. So we're separated right now into manufacturing, power generation, fuselage, wing, aerodynamics, controls, propulsion, and landing gear. So to start, as Lakshan went over a little bit, manufacturing has been working on getting the RQ-11s up and running, making sure those fly properly, and then with the help of different members of all the different teams, we've been getting all the carbon fiber put together, getting the entire plane built, and they're actually working on that up in the lab right now. Power generation is our solar panel and electrical team, so they've been working on finding which solar panels we need, how much power do we need to generate for sustainable flight, and then actually custom building solar panels and assembling the different cells from our batteries that we've had to be able to put into our plane. Fuselage was in charge of building and designing the entire fuselage, so they did many iterations of different shapes, a lot of finite element analysis to see how the shapes would hold up under different circumstances. That fuselage has been built, but we ran into some weight problems. That one's on hold for right now. Wing was deciding different types of airfoils, what would be our best option. We also have another team, Delta team, which has been working on a Klein Fogelman airfoil. Mr. Fogelman, we've actually had a little bit of contact with him. Since it's not a very used airfoil, it's a stepped heavy lift airfoil, since it's only been in production for mostly RC planes. That's something we're looking into relatively. Aerodynamics was doing all of our skin friction and drag calculations to make sure that we had enough power. So they were working directly with propulsion and landing gear to provide motors, see how much power and everything we were needing, and then a basically talking to power generation about consumables. And controls is Moon's team working on the software, making sure the plane flies and flies where it's supposed to, depending on different calculations.
Alright, so here are some images of the wings. The initial plan was we have carbon spars running along the airfoils, and we got the airfoils cut from Rapidtech, and it's made from balsa. And then we have carbon twine running across to give it some shape, while we apply the carbon fiber layer on top of that. And as you can see here, it's like that's how the wings look attached to the fuselage. And it looks nice, but again, we ran into a lot of the issues where it started to contour in at some points, and resin was not really that friendly with working around, and resin got everywhere. But at the end of the day, it looks really nice, and it's very light. One of the biggest goals we had was weight reduction, and we achieved that by doing this.
I think our current weight is 12 pounds?
It's 9.88.
Okay, that was with landing.
So basically, we had to restructure our fuselage because the original idea we had was 9 feet long, and it was turned out that running the layers of fiberglass through, and it turned out it wasn't that structurally sound, and to get it to be structurally sound, we would be adding a lot more weight. And that's where the idea came that we need to approach the fuselage in a different direction, and we came to the idea of having a tube-like structure, which would house all the batteries and the APM and have everything connected inside, while being the easiest to work around with carbon fiber. So this is an image of the solar cells that we were using. I believe the panels that we connected and tested outside, we got about 20 watts.
Yeah. Small number of panels, we're still getting 20 watts.
So,
watts.
Yeah, around that range. And from that on, for next year, we'll be expanding it to include, basically build our own custom solar panels that sit on the plane.
Yeah, as Lakshan was saying, due to a change in the fuselage design, we've had to move the solar panel integration in the fuselage to a later quarter, mostly since we don't physically have the real estate space to put those on right now. But everything else has been ordered, everything is there to be able to put the solar panels in, layer the Lexan, everything on top of it, and get it fully integrated.
So for controls, we're done with our search code, which I think that we were done with this slightly earlier this quarter. We had an issue with we use the Mavlink support instead of mission planner, and what it does is it reads the text files that we output using our code. So what we're ready to do right now is just to put in the autopilot into the plane, and somehow not fully automated, but we would have to input the data through a USB, and then from there the plane will take off and follow the search pattern that we designed it to have. Obviously, that's not what we set out to do in the beginning of the year. We wanted to do that wirelessly so that the plane would be flying, and we would send the data to it, and it would do all of that on its own. However, we'll just probably push that to next year and see where it takes us from there. But besides that, the plane is ready to fly, given our code and given the data needed to fly. So yeah, pretty much what we have to do right now is we have to somehow find a way to mount the landing gear, solar panel. We're probably gonna scratch that. This is like one of our most recent developments, and we're just ready to fly. I think anytime next week, probably, right? Mm-hmm. Yeah.
Together.
And
we thought that we would have more juniors.
Yeah, so for next year, we'll be looking to try to get more juniors into the project. It'll be more of a research and development phase where we actually go back to the drawing board and find a design that would work best for our needs again. And now that we've actually attacked the manufacturing part of the process, we know what are going to be the setbacks and how we need to better form like a better communication link between the team members. And like we had conflicts when it came to ordering stuff, and slight mishaps were happening, and that would be a big focus for next year to get that cleared out. And basically the structure would be that fall quarter would be us designing about, going about trying to figure out VTOL controls, and basically designing a 3D model of the whole fuselage, the whole plane that works. And then winter would be us manufacturing it. And would it be spring? That's the plan, to get the controls team to basically work. Once we know that the plane is sound, we can have test runs through that and get it ready.
That's it. Thank you.